We operate on Taylor series term by term. So if we have our Taylor series a naught plus a1 x and so on and so forth, when we take the derivative, well, the derivative of a constant disappears. The derivative of a1x just becomes a1. The derivative of a2x squared becomes 2a2x, and so on and so forth. In other words, when we differentiate a Taylor series, we just do it term by term. Similarly, when we integrate a Taylor series, if this is our Taylor series, and this is a standard form for a Taylor series, we just integrated term by term. So we have to add a plus c because we didn't have one before. The a naught became a naught x, the a1x became 1 half a1x squared, and so on and so forth. In other words, we're doing it term by term by term. And now let's see, let's just go over here to addition. If we add two Taylor series, we just add them term by term. So if a naught was the constant of the f function and b naught was the constant of the g function, then a naught plus b naught is the constant of the f plus g function, and b1 plus a1 plus b1 is the coefficient of x in the new added function, and so on and so forth. That's how we add. That is how we add. Now here we have our basic Taylor series. So if I'm going to add 1 minus x to 1 plus x, so 1 plus 1 is 2. These guys cancel. X squared plus x squared is 2x squared, and so on and so forth. And I could add any terms. If I'm going to add e to the x plus e to the negative x, 1 plus 1 is 2. These guys cancel. That becomes 2 of these. The next ones cancel, and so on and so forth. I'm not saying you have to only add ones where we have the serendipitous canceling, but I'm just picking those examples because it makes it kind of easier. Anyway, this is how we roll with Taylor series. Sorry about that. And I just want to go to one last thing, which is a little trickier. If we have f of x is a function that's represented by a Taylor series, that's our f of x. We can multiply the entire function by c times x to the r power. C is any constant, x is our regular variable, and r is any exponent. And then what we wind up getting is basically, again, it's term by term. Each term gets multiplied by that cx to the r. So a naught becomes a naught times cx to the r. You see that? a1x becomes a1 times c x to the r plus 1, because I already have an x to the 1. Now I'm multiplying by x to the r. My exponent is x to the r plus 1. Here it's x squared becomes r plus 2. The c, a2, everything term by term becomes the same, and that's how it works, term by term. Just like college works term by term. Isn't that awesome?